Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an oblique right hexagonal pyramid having base edge 30 millimeter, axis height 65 millimeter, which is resting on one of its base edges on the horizontal plane such that the triangular face containing that side, it is perpendicular to the horizontal plane. So let us first of all evaluate the orientation of this hexagonal pyramid onto the horizontal plane. So if we locate the hexagonal pyramid onto the horizontal plane in this orientation and then we incline or tilt this hexagonal pyramid with respect to the horizontal plane, so it will be resting on one of its corners onto the ground. So it will not be resting on one of the base edges on the horizontal plane. And further, the triangular face which is containing the edge, it should be perpendicular to the horizontal plane. So this condition will also be not fulfilled by this particular orientation. So this orientation of the hexagonal pyramid onto the horizontal plane, it is incorrect. Whereas if we locate the hexagonal pyramid onto horizontal plane into this orientation and then through this apex, if we tilt this hexagonal pyramid with respect to the horizontal plane, so now the hexagonal pyramid will be resting onto the ground on one of its base edges over there. And further, the second condition which should be satisfied over here, that this triangular face O, D and E over here. So this is the triangular slant face of this hexagonal pyramid. This should be perpendicular to the horizontal plane. So we have got pyramid resting on the horizontal plane on the edge of the base DE, while the triangular face which is going to contain this particular edge of the base DE, that is ODE, it should be perpendicular to the horizontal plane over there. So if we locate the hexagonal pyramid into this orientation, so both of these conditions, so they will be satisfied over there. Then in the second iteration, we have been providing with the information that the edge onto which it is resting on the ground, it is further rotated in such a way that it becomes parallel to the vertical plane. So please check, to begin with, this edge happened to be perpendicular to the vertical plane. So whatever top view projections we are going to obtain after inclining this hexagonal pyramid with respect to horizontal plane in such a way that this triangular face of the hexagonal pyramid becomes perpendicular to the horizontal plane. So the top view projections which are obtained thereafter, they have to be rotated 90 degree, because earlier this edge DE happened to be perpendicular to the vertical plane. So the top view projections, once we rotate it by 90 degree, then this edge DE will become parallel to the vertical plane. So this way, this is the case of a hexagonal pyramid which is initially inclined with respect to the horizontal plane, and further it is inclined or rotated with respect to vertical plane at an angle of 90 degree. So this becomes an oblique hexagonal pyramid for which the orthographic projections of the solid have to be obtained over here. Now with this information, let us proceed with the construction of orthographic projections of the right hexagonal pyramid which is resting on its base onto the horizontal plane. So here we have already discussed that two of the edges, they will be perpendicular to the vertical plane. So here we have got the XY reference line. So we know that the edge of the base of the hexagonal pyramid happens to be 30 millimeter. So when the observer is going to look at this hexagonal pyramid from the top, so observer will be viewing the hexagonal projections of this pyramid onto the horizontal plane. Now we have drawn the hexagonal projections of this pyramid on the horizontal plane, that is below the XY reference line. We have to draw these hexagonal projections over here. So the edge of the hexagon, we have been provided that it is equal to 30 millimeter. Now in order to obtain the axis points, now we have to join the diagonals AD, BE and CF over there. So wherever these three diagonals they intersect with each other, we obtain the axis point O and O1 over here. And whenever the observer is looking at this pyramid from the top, so all the six slant edges OA, OB, OC, OD, OE and OF. So all of these six slant edges, they will be visible to the observer from the top. So this way we have completed the construction of the top view projections of the right hexagonal pyramid resting on its base onto the horizontal plane. Now let us proceed with the evaluation of the front view projections of this hexagonal pyramid. Now here we know that the axis height of this pyramid, it is equal to 65 millimeter. So we have marked this axis height is equal to 65 millimeter over here. So this apex point O, here we have the apex O over here. So once we mark this axis height is equal to 65, so now the apex point O dash has been located. So the moment we locate this point O dash over here, now we can proceed to join O dash B dash, O dash A dash, O dash C dash, O dash F dash, O dash D dash and O dash E dash over here. And this is the access point of the base O1 dash. But here one thing we need to remember, that these are the three slant edges OA, OF and OE. So these three slant edges, they are lying on the rear side of the solid, which are not visible to the observer from this direction. So this edge OA, it should be represented as a dotted line or a hidden line in the front view projection as O dash A dash. But this edge OA is superseded by, or it is overlapped by edge OB, which is visible to the observer from the front. You can see this is the edge OB. So this will be overlapping the edge OA. So OA is not visible while OB is visible. So this hidden line of O dash A dash will be superseded by the object line of the edge O dash B dash. So O dash B dash front view slant edge projections, they are going to supersede or overlap dotted line projections corresponding to O dash A dash over here. Similarly over here also, OF edge will be superseded or overlapped by the edge OC. Therefore here also the hidden line projections corresponding to the edge O dash F dash have been superseded by the object line projections of the edge O dash C dash over here, right? Similarly over here we have got OE, it is to be represented as a hidden line in the front view projection as O dash E dash, whereas O dash E dash slant edge will be superseded or overlapped by the edge OD over here. So O dash D dash object line projections, they are going to supersede or overlap the dotted line or the hidden line projections corresponding to the edge OE, that is O dash E dash over here. So this way we have been able to obtain the front view projections of the right hexagonal pyramid resting on the base in the horizontal plane. Now we have been provided with the information that this hexagonal pyramid will be tilted in such a way, it will be rotated in such a way through this apex such that it will be resting on ground on one of its base edges DE over here. So this is the base edge DE onto which it will be resting. So when it will happen, when I rotate this hexagonal pyramid through this axis over here in this direction, but another condition has to be satisfied, that this triangular face ODE, which contains this base edge which is resting onto the ground, So this triangular face ODE. So here we have got, you can check, edge view corresponding to this particular slant face over there. So this is the triangular face we can check in the top view, ODE. So this triangular face whose edge view is available over here in the front view projections as O dash, D dash and E dash. So this will be rotated in such a way that this slant face, which is ODE, it becomes perpendicular to the horizontal plane. So now into the new orientation we have to rotate, or we have to transform the elevation projections of this right hexagonal pyramid from the original elevation projections into the new orientation over here. So to begin with, we know that this triangular face ODE, that is O dash, D dash, E dash. So this edge view we have to rotate in such a way that it becomes perpendicular to the horizontal plane. So we can draw this edge view, height is equal to O dash, D dash, E dash. Now what we have to do in order to transfer this elevation projection of the hexagonal pyramid, so we have drawn D dash, O dash over here. So this is O dash, D dash, E dash over here. Now we know this distance, that is D dash, E dash and B dash, A dash. So this distance we are going to measure. So through this point as our center point, we are going to mark one arc over here using this distance, which is equal to D dash, E dash and B dash, A dash over here. Then through point O dash, we will measure the distance of this slant edge. So whatever is the length of this slant edge, that is distance of O dash, B dash, A dash. So through this point O dash, again we'll open the same distance as O dash, B dash, A dash. Again mark another arc over here. So wherever these two arcs they will intersect, so this point B dash, A dash will be located over here. So once we locate B dash, A dash over here, so the 3 points of this triangular projection they have been obtained. Then we know this distance as well. So once we measure this distance, we can plot a point over here onto this particular edge, which is the base of this particular hexagonal pyramid. So once we mark this edge, so the points C1 dash, F1 dash and O11 dash, they will also be obtained. Now we can see we have transferred all the points from the original upright hexagonal pyramid elevation projections into the new transformed view when the hexagonal pyramid has been tilted or reoriented with respect to horizontal plane in such a way it is resting on the horizontal plane on one of its base edges, and it is having one of its triangular faces O1 dash, D1 dash and E1 dash perpendicular to the horizontal plane. So this is the perpendicular which we have drawn over here. Now having obtained the elevation projections corresponding to this inclined hexagonal pyramid, now we are required to draw the corresponding top view projections of this inclined hexagonal pyramid. So how that can be done? Now how many points do we have in this view? There are 6 points corresponding to the base and 2 points corresponding to the axis which are available with us in the elevation projection view. So as the observer is going to look at the solid from the top, so these 8 points they are available in the elevation projection view, they will be projected into the plan projection view. So vertical projectors through these 8 points, we are going to draw and extend them into the plan projection view, and then from the plan projection view, the horizontal projectors will be drawn from the plan projection view which we had obtained earlier, and the corresponding intersection points of the horizontal projector lines drawn through the plan projection view and the vertical projection lines drawn through the elevation projection view. So they will be providing us with the locations of the elevation projection view of the inclined hexagonal pyramid onto the horizontal plane. So let us proceed with evaluation of the plan projection points for the inclined hexagonal pyramid. So here we have the point F. Through point F we have drawn a horizontal projector line. So wherever this horizontal projector line will be intersected by the vertical projector line drawn through the point F1 dash, we are able to obtain the point F1 in the plan projection view. Now the next 2 points which are available with us, they are A and E. So through A and E, once again we have drawn a horizontal projector line. Now wherever this horizontal projector line drawn through the points A and D, it will be intersected by the vertical projector lines drawn through A1 dash and E1 dash. So we are going to obtain the points A1 and E1 over here. Next 2 points we have over here is O and O1. So again we have drawn a horizontal projector line through the points O and O1. Now wherever this horizontal projector line drawn through O and O1, it will be intersected by the vertical projector lines drawn through O1 dash and O11 dash. So we are going to obtain the points O1 and O11 over here. Next we have got the points B and D. So through points B and D we have drawn the horizontal projector line, and wherever this horizontal projector line drawn through these 2 points B and D, it will be intersected by vertical projector lines drawn through B1 dash and D1 dash. So we will be able to obtain the points B1 and D1 in the plan projection view. And finally we have got the point C. Now through point C we have drawn a horizontal projector line. Now wherever this horizontal projector line drawn through the point C, it will be intersected by the vertical projector line drawn through the point C1 dash. So we have obtained the point C1 over here in the plan projection view. So all the 8 points corresponding to this inclined hexagonal pyramid, they have been appropriately located into the plan projection view. Now which of the edges we have to join? A1 B1, B1 C1, C1 D1, D1 E1, E1 F1 and F1 A1. And also we are required to join O1 A1, O1 B1, O1 C1, O1 D1, O1 E1 and O1 F1. Now which one of these edges they should be drawn dark or using the object line? Which one of these edges they should be drawn using hidden line or the dotted line? Let us evaluate. Now as the observer is going to look at the solid from the top, so the farthest point away from the observer, they happen to be D1 dash and D1 dash. So all the edges joining D1 and D1 in the top view projections, they should be drawn dotted unless they are falling into the boundary of the solid. So let us first of all join the boundary of the base over here. That is A1, B1, C1, D1, E1, F1. So once we join the boundary, now we can see over here. Earlier we said that any edges joining D1 and D1, they should be drawn dotted. But then the edges C1, D1, D1, E1 and E1, F1, they are falling into the boundary of the solid. So we cannot draw these edges dotted over here. So these 3 edges, they will be drawn as object line projection or the solid line projections over here. Now let us join apex with all the other points of the base. So here we have the apex as O1. So O1 A1 will be dark, O1 B1 will be dark, O1 C1 will be dark, O1 F1 will be dark, and now O1 E1 will be dark because it is falling into the boundary. Similarly, O1 D1 will also be drawn dark because it is again falling onto the boundary. So this way, none of the edges we have got as hidden edges over here. So all the edges, they are visible because most of them, they have fallen onto the boundary of the object. So now the top view projections of this inclined hexagonal pyramid, they have been obtained. And now the front view and the top view projections of this inclined hexagonal pyramid, they have been appropriately obtained when the pyramid was inclined in such a way that it was resting on one of its base edges onto the horizontal plane, and one of the triangular faces, that is ODE, it happened to be perpendicular to the horizontal plane. Now, as we look at this particular edge, D1E1, now this edge D1 dash E1 dash, it is contained by the horizontal plane. So since this edge of the base D1 dash E1 dash is contained by the base or contained by the horizontal plane, so the top view projections D1 E1 happen to be true length. So now we have been provided with another information that in the second iteration, the edge of the base onto which the pyramid is resting onto the ground, it is rotated in such a way that it becomes parallel to the vertical plane. Now we can see over here, this edge, earlier it was perpendicular to the vertical plane. So now the plan view projections over here, they have to be rotated by 90 degree. So we have to rotate them 90 degree over here in this way. Please check. In this way I have to rotate it 90 degrees such that E1 D1 will be represented as an edge which is no longer perpendicular to VP, rather it becomes parallel to VP. Now we can see that the plan projections which have been obtained corresponding to this inclined pyramid, they can be inscribed into this rectangular construction over here. So this longer edge we know, this shorter edge dimension we also know. So we know the dimensions of the longer edge as well as the shorter edge of this rectangle. Now using the principle of transferring the rectilinear distances, now we are going to rotate this plan projection view which we had earlier obtained corresponding to this inclined hexagonal pyramid. So let us have the rotation or translation of this plan projection view such that the edge D1E1, it becomes parallel to the horizontal plane. That is, we have to rotate this plan projection view by 90 degree. So here we have transferred this rectangular construction over here. Now we can check. This is the longer edge and this is the shorter edge of the rectangle. Please check. This was the longer edge of the rectangle and this was the shorter edge of the rectangle. Now we can see over here alongside the longer edge how many points we can have. 1, 2, 3, 4 and 5. So corresponding to points 1, 2, 3, 4, 5. Now we will be measuring the corresponding distances between these 5 points. So point 1 will be located over here. So 2, 3, 4 and 5. So whatever is the distance from this edge of the point A1, we are going to mark it over here. Whatever is the distance of point A1 from this axis point, we'll mark it over here. Whatever is the distance of this axis point from B1, we will be marking it over here. And whatever is the distance of B1 from this edge, we have marked it over here. Similarly, on the other side, this is the shorter side. So we know this distance and we know this distance. So we have marked these two distances over here. This distance and this distance we have marked. So now we have obtained the grid line where all these 8 points which we had earlier obtained in the plan projection view, so they will be transferred over here. So here we can see point A2 will be located here. This will be the point B2. Here we will get C2 point, then D2, E2 and F2 over here. So this will be our point O2 while this will be our point O21. So this way all the 8 points of the previous plan projection view have been transferred into the new orientation where D2, E2 should be parallel to the vertical plane. So earlier this D2, E2, that is D1, E1, it happened to be perpendicular to the vertical plane. So this plan projection has been rotated by 90 degree such that the edge of the base D1, E1 onto which it was resting, now it has been made to become parallel to the vertical plane by rotation of 90 degree. Now this way we have been able to obtain the plan projection view corresponding to this oblique solid which happens to be inclined with respect to HP and inclined with respect to the vertical plane. So now we are required to obtain the elevation projection points corresponding to this oblique hexagonal pyramid over here. So how that can be done? As the observer is going to look at this pyramid from this direction, now there are 8 points available over here into the plan projection view. Now through these 8 points, we are going to draw the vertical projector lines and extend them into the elevation projection view in such a way that these vertical projector lines, they should be intersecting with the horizontal projector lines drawn through the elevation projection view which we had obtained previously over here. So let us proceed with evaluation of elevation projection points corresponding to this oblique hexagonal pyramid. So first of all, we have got point O1 dash. Through O1 dash, we have drawn a horizontal projector line. Now wherever this horizontal projector line drawn through the point O1 dash, it will be intersected by the vertical projector line drawn through the point O2. So this intersection point will provide us with the location of the point O2 dash in the elevation projection view. Next, we have got the points B1 dash and A1 dash from the previous elevation projection view. So from B1 dash, A1 dash, we have drawn a horizontal projector line. Wherever this horizontal projector line will be intersected by vertical projectors drawn through A2 and B2. So we are going to obtain the points B2 dash and A2 dash in the elevation projection view. So now we have got 3 points over here, C1 dash, F1 dash and O11 dash. Now through these 3 points which are converging with each other, we have drawn a horizontal projector line, and wherever this horizontal projector line drawn through C1 dash, F1 dash and O11 dash, it will be intersected by vertical projectors drawn through C2, F2 and O21. So we are going to obtain the 3 points C2 dash, F2 dash and O21 dash over here. Finally, here we have got D1 dash and E1 dash, onto which this hexagonal pyramid is resting onto the ground. Through these points D1 dash and E1 dash, again we have drawn a horizontal projector line which is coinciding with the XY reference line over here. Now wherever this horizontal projector line drawn through D1 dash and E1 dash, it will be intersected by vertical projector lines drawn through D2 and D2. You see, this is vertical projector line through D2 and this is vertical projector line through E2. So these 2 points will provide us with the location of D2 dash and E2 dash over here. So this way, all the 8 points of the oblique hexagonal pyramid, they have been obtained in the elevation projection view. Now which are the edges which we have to join? A2 dash, B2 dash, C2 dash, D2 dash, E2 dash, F2 dash and A2 dash. And also we are required to join O2 dash with A2 dash, O2 dash with B2 dash, O2 dash with C2 dash, O2 dash with D2 dash, O2 dash with E2 dash and O2 dash with F2 dash. But which one of these edges they should be joined as dark lines or object lines, and which one of them they should be joined as hidden lines or dotted lines? So let us evaluate. Now as the observer is going to look at this solid from this side, so A2 and B2, they are the points which are farthest away from the observer. That is, in the front view, A2 dash and B2 dash will be the points through which whichever edges they are joined, they should be joined as dotted lines or the hidden lines, unless those edges they are going to fall into the boundary. So now let us join all the edges of the base over here. Now we can see A2 dash, B2 dash, it is not falling into the boundary. So this has to be drawn with the help of a hidden line or a dotted line. Similarly, B2 dash, C2 dash, again it is not falling into the boundary. So again it has to be drawn or joined using a hidden line. And similarly A2 dash, F2 dash is also not falling into the boundary. So these three edges of the base we have drawn as dotted line. Why? You can see as the observer is going to look at the solid from this side. So these three edges, they are lying on the rear side of the solid, which will be covered by this surface of the solid over here. Similarly, the slant edges O2 dash, B2 dash and O2 dash, A2 dash have also been drawn as hidden lines because they will be appearing on the rear side of the solid over here. Now if we join H O2 dash and D2 dash and O2 dash and D2 dash, these two slant edges, they will be visible to the observer over here. Now we can join the axis, that is O2 dash and O21 dash over here. So the axis of this pyramid has also been located into the elevation projection view. So with this, we complete the discussion regarding obtaining the orthographic front view and top view projections of this oblique hexagonal pyramid when the pyramid is inclined with respect to horizontal plane in such a way that it is resting on one of its base edges DE onto the horizontal plane and one of its slant surfaces ODE happens to be perpendicular to the horizontal plane over here, and further the edge DE onto which it was resting onto the ground, it has been rotated to make it parallel to the vertical plane, and these are the projections of the oblique hexagonal pyramid that we have been able to obtain. So this is all for today. So I hope that through this discussion you would have understood about the procedure how to evaluate the orthographic front view and top view projections of the hexagonal pyramid when the pyramid happens to be inclined with respect to HP and VP. So we will be continuing with further discussion regarding few more illustrative cases of projections of the oblique solids in the coming lectures. So thank you very much. Thanks a lot.